Hi everyone, welcome to today's online training session. So my name is Simon Grandet and I'm the photogrammetric workflow specialist here at SimActive. So today the topic of my presentation will be how to share and visualize drone project in the cloud. So it's going to be a two section presentation. I'll start by talking a bit about the cloud, then we'll go through how to process some UAV data, and at the end of the presentation I'll show you how you can manage an account, create customizable links to send to your customers, and how you can export your project data on the cloud. So as many of you may know, exporting data to the cloud is something that we have just released with our latest version, Correlator 3D 8.5. It's one of our two main breakout that we've done with this specific version. The other specific element is the radiometric calibration for the multispectral data. But today the topic will be how to share and visualize your data on the cloud. So what are the main advantage to share and visualize your data? Is basically you can share quickly some links with your customers to show you the progress of your project. So you can send them just links with the DEM, with the point cloud to show you where you are in your project. Also, it's a good alternative to GIS software for only visualization. It can be much more simple than using a typical GIS software to do such manipulation. And also, Cesium is the tools that we have selected for our online viewer, is a built-in solution directly with Correlator 3D. So it's really simple to use, as you will see later in this presentation, and the user does not have too much about manipulation to get this data on the cloud. So today what you will learn during this presentation, I will start by what is a cloud-based sharing platform. Then we will go into the workflow of the UAV project. Also, I will talk about how to export the result to the cloud, creating shareable links, web links for your customers. And finally, I'll show you how to visualize your geospatial data online with a SimActive online viewer. And finally, at the end of this session, I will answer a question that you have during this presentation. Again, if you have some questions, feel free to ask them in the chat box, and I will try to answer them as best as I can at the end of the presentation. So let's talk about a bit of Correlator 3D. So Correlator 3D is a photogrammetry software which is patented to have the first GPU-based photogrammetry software. And it's a software that recognized to have a higher processing speed than the competition. We can process different types of projects such as drone, satellite, large format. But today, this presentation will focus about UAV processing for this presentation. So what is a cloud-based sharing platform? So basically, what is Cesium? So a cloud-based platform is a cloud file sharing, also called cloud-based file sharing or online file sharing. It's a system which a user allows to storage space on a server that allows you to read and write over the net. So basically, you have an account on Cesium, which gonna give you the possibility to upload some data and share the links to your customers. So what is Cesium? So Cesium IN is a robust, scalable, and secure platform for 3D geospatial data. You can upload your content, and Cesium will optimize it, tile it for the web, and it will be served up in a cloud and streamed to any device. So you will have access to all your data on your cell phone, on your tablet, on a computer, anywhere where you can have access to the link with your shareable content. So finally, combine these assets with your own data to provide more context or to see it on a 3D map of the world. So you will be able to see all your data on a 3D globe or just visualize it on a Cesium platform. So now that I've talked a bit about what is Cesium and what is the cloud sharing, let's talk about the workflow for drone project. So basically, the workflow is quite typical for a standard UAV project. It's just breakdown in maybe 4 categories. So the first categories will be the aero triangulation, which is breaking down in 3 to 2 steps. Then you will have the DEM extraction, the ortho rectification, and then the mosaic creation. So the first step, as I said, is the aerial triangulation, which is basically trying to find common features between all the images to retrieve a nice block of images all tied together. Then, if you want to refine the overall absolute accuracy of your model, you can use GCP's checkpoints to assess this accuracy. And at the end, basically, we're doing a bundle adjustment. So we're refining the position of the camera, also the interior parameters known as the camera distortion of the camera. And then yeah, once the bundle adjustment is performed, you can then extract a digital surface model and a digital terrain model from your input images. But again, this will be the output result will be based on the resolution of the input imagery. Those outputs can also be generated with a point cloud. That is optional, but the user also have the choice. Again, you can perform some DEM editing if you want to maximize the output results to get more accurate results. And then you can choose between the DSM and the DTM for the ortho rectification. From the ortho single image, you can then create a mosaic, and once all those outputs are created, you will be able to share your content over the web. So now we have seen the workflow. Let's see how it transpose within Correlator 3D. So here, as you can see, you have the visual interface of Correlator 3D, which is quite intuitive for non-typical user of Correlator 3D, but it's really easy to get your hands on and really quickly learn how it works. So basically, the buttons on the top here are all the steps that you need to perform in order to process all your data before sharing it on the cloud. Again, as soon as you get an output done, such as a DSM, DTM, you can then share those outputs on the cloud, or you can wait until the end of the project to share it on the cloud. So the first 2 buttons here are to open or close, are to open or create a new project. I won't go today into the overall project creation. But again, if you want to learn a bit more about the project creation, you can go on our website and we have tutorials to do so. Then we have the automated workflow, which is basically a one-button click solution, which allows you here to have all the tools into into one module, one module. So the software is gonna go step by step between all the modules, and will generate your output. So you're gonna have different profile based on the output that you want. Another great thing with the automated workflow is you can generate some script if you want to go, if you want to not to go via the GUI interface, but if you want to do some batch processing. So you can just check the little box here like this, and you can process it like this, and it will automatically generate a script based on the project that you have opened previously. So again, the other alternative to the automated workflow is going step by step, which is really what we recommend here at SimActive, because it's gonna give you the full possibility or the full control over all your data, and it's gonna give you the best result possible because you can maximize the editing, and also you can have control on all the parameters that you want for your photogrammetric project. So the first step here is the arrow triangulation module. So at first, when I will launch the arrow triangulation module, the software will ask me if I want to extract some type points. So basically, the type points are common features that we can find between consecutive images or closer images one to the other, and are key parts for reconstructing the 3D model of the scene. The type point extraction is highly dependent on the overlap of your project. So again, for a typical UAV project at SimActive, we recommend having a side overlap of maybe 50% minimum, and a front overlap of 70%. You can also raise this to 60 side lap and 80 front lap, but maybe not going higher than that, because it will just create more data than you have to. So the overlap is a key part for the 3D reconstruction. Depending on the texture or on the flight altitudes that you have, you will maybe need to adjust the overlap of your project, and also the flight configuration that we are suggesting is having parallel flight line and at a good altitude. And also, prior to creating your project, it's a good practice to clean the data. So removing the landing and takeoff imagery and all the turning imagery. So you really only keep what is the images that are there for the photogrammetric processing. So once you're ready to extract the type points, we have two types of type point extraction, such as the standard and the exhaustive extraction. The standard will work with 95% of the case, and in the project where you have maybe low texture or the overlap is quite low, you can also use an exhaustive extraction. So basically, the exhaustive extraction will be for a project maybe where you have large water bodies or you have dense vegetation, where we can have a hard time to find common features between all the imagery. So once the type points are extracted, you will have something like this. You will have all those little red dots which correspond to each of the imagery that the position did not get optimized yet. But you will also see all the different white lines that corresponding to links between all the imagery. So I can open one link quickly, and I can see that those lines are corresponding to common features between those two images. All the other little dots are type points that were found with other imagery in the neighbor in the neighbor. Again, you can also display the type points. So you can display it like this, and you can, let's say, click on one type point, and you will see on all the images that this type point was found, and you can assess the overall accuracy of those type points. Once you have extracted the type points, you can then import your ground control points or your checkpoint if you have access to it. If not, you can also process any project without ground control points, but the use of ground control points will refine the absolute accuracy of your project. So you can import a ground control point within a text file like this. So you can bring in the text file, and then you will be able to select your the header of each columns. You can also specify the type of ground control points that you want. Is it the 3D GCPs, a planimetric ground control points, an altimetric ground control point, or only a checkpoint. So basically, the difference between a checkpoint and a ground control point is that the GCPs, or the ground control point, will be used to adjust the bundle adjustment, and the checkpoint will be there only to assess the overall accuracy of the bundle adjustment without having any impact on the overall adjustment for the bundle for the bundle. Once your GCPs are bringed in, you can tag them like this, and so you can precisely mark the middle of the data or the marker on your images, and then you can do it so for all the imagery like this. Once all your ground control points have been tagged, you can then generate or execute the bundle adjustment. For a typical UAV project, you will leave the EOS adjustment to fully AT unconstrained, the sensor calibration to unconstrained, and the ground reference can be used as ground control points. Again, if you want to have more information about how to process or to handle the different parameters of the bundle adjustment, I suggest you go on our website, since we have a complete webinar that we did on the AT section of a UAV project or a mapping project. So once the bundle adjustment is done, you can review the overall result. So you'll see that now all my images are green because their position has been optimized. The camera parameters have been retrieved and optimized. And I can, from there, generate a surface model from those input imagery. Once the bundle is done, we also providing a quality report in a PDF, which will give you here the basic overview of the project summary. So you're gonna have the project type, the image type point adjustments, the control point, and also checkpoints if they were used. You're gonna also have other information about the bundle adjustment parameters that were used, the aerial triangulation overview, the overall block adjustments, the sensor calibration, the individual ground control points error analysis around here, and at the end you will have the specs of the computer that was used. Again, once this is done, you can then generate a surface model from the input imagery. So by default, Correlator 3D will generate an optimal resolution, which is 5 times the ground sample distance of the input imagery. You can also specify your own resolution, so you can set it up. You can manually change the value. Usually, we recommend between 3 to 5 times the ground sample distance because it's a good ratio between speed and accuracy of the output. But the final resolution is really regarding the output that you want to deliver to your end customers. If you only want to generate some ortho and the customers are not interested by the DEM or the DSM, having maybe something at 5 to 10 uh, time the GSD of the imagery can be something really good. You can also generate a point cloud at the same time of the. You can also generate a point cloud at the same time, and the output will be stored into the project tree. So you're gonna have a DSM like this, which is a 2.5D representation of your scene. From this DSM, you can also extract a terrain model. So we have an algorithm tools that's going to remove everything that's not terrain related, such as building, trees, cars. And at the end, you will only have uh, here in this case the stockpile from this terrain model. So the terrain extraction is an automatic tool which the user can import a few constraints such as maybe exclusion zone. So here the exclusion zones are shapefile that you can draw directly in the software, where you don't want to the software to extract the terrain model or to smooth it out elements from the surface model. So in this case, I wanted I wanted to keep the stockpile as intact as possible. So I decided to create an exclusion zone to keep this area intact for the ortho rectification. From there, you can select either the DSM or the DTM to do the ortho rectification. So in this case, I can select the DTM to perform the ortho rectification, and um, here I will be able to perform the ortho rectification. So the ortho rectification will create an individual images that is ortho rectified based on the selected elevation model. And all those individual images will be used to compute the final mosaic at the end. So the main settings here are that you can set the overlap that you want to keep between all the orthos, or you can also crop them depending on the size on the size of your project. Once the ortho are selected, you will have here all the individual files that you will be able to see like this, and compute the final mosaic from this from those individual ortho. At the end, once the mosaic is created, you will have a final mosaic like this, which is a seamless color balance mosaic. But you can also do some modification to this mosaic, so you can edit the overall seam line of your mosaic. You can also play with the histogram of the mosaic if you want to adjust the final color of your project. So here you can select maybe one line like this, and you can move the dots of this seam line if you want to make it even better. Again, here you can adjust the overall color of the final mosaic. So I can play with the histogram of the color, add some brightness, or I can play with the master band, or I can even play with each individual band depending on the input that I had and on what the output I would like to deliver to my customers. You can also export your seam line and then export the mosaic as a geotiff file. And here, a new feature that we added in the 8.5 version is we can now export the mosaic with a JPEG compression, which is going to reduce significantly the size of the mosaic. So when you have large project, but you don't want to have a huge file, you can use a JPEG compression for the mosaic exportation. Finally, the last modules that we have before sharing your content on the internet is generating the 3D model. So the 3D model is basically a 3D mesh. So we're gonna use the digital surface model to create a mesh and then texturize this mesh with the input imagery, and the output will be stored as a Node.js format. So at the end, once all your output have been created, so you're gonna have a DSM, a DTM, maybe a point cloud, a mosaic, and a 3D model. All those output can be then shared on the web via Cesium. So now that we have seen the UAV typical workflow, let's jump into the main subject of this presentation on how to visualize and share your data over the cloud. So basically, what are the steps in order to be able to share your content on the cloud? So first of all, you will need to create a Cesium account. So you can go at www.cesium.com. You can find the link in our user manual also if you want to create an account, and I will be able to post it in this presentation again. So first of all, you will need to create an account, and from there they have different options of account. So they have account. They have free account up to business account, depending on the storage capacity that you want for your subscription. For most of our users, the free account will be suited. So again, if I show to you here, so you will have something like this. So the first thing is, when you're gonna create your account here, you will have a window like this that will appear, and the first thing you will need to perform is to create some token. So basically, the token are the information that will allow you to upload and share the output. So basically, once you have login to your Cesium account, you will need to go here into access token, and then create a share and an upload token. So basically, the first thing is you would like to create an access. The first token will be the upload. So you can create here a token. You can name it upload like this. Upload. And for the upload, it's really important that in the scopes, all the sections here are turned on, and then you can leave here the resources to all assets, and then create the upload token here. And what's important is here, the token that you will have here will need to be brought in Correlator 3D in order to share your final output to your customers. So from there, you will need also to create another token, which will be the share token. So you can create the second token that will be called sharing, like this. And for the sharing here, what you will have to do is basically you will have to only here at the read the read option, and the resources will be all assets, and from there you can create the sharing token. So once you have generated your token, you can go back into Correlator 3D, like this. And then within the file modules, so you can go into file, and then here you will see a button which called share button. Um, so you will have something like this here that you will see. And also here you will be able to create your Cesium profile, or in this case I could add, let's say, a profile. I will add a profile. I can then type in my name associated with this profile. I can tap a description of the profile. And here, as you may see at the bottom, you will have the upload and the share token button. So it's at this step where you're gonna go through your Cesium account. You're gonna take here the sharing token. You can here copy to clipboard, go back into Correlator 3D, and then paste it like this, and do the same thing for the upload um, section. So I can go back here within um, the sharing. Sorry, in the upload, I can copy this, and from there I can paste it like this. So again, I have both upload and share. I can click on OK, and this will bring me back here to my share result window. At this point, depending on the outputs that I have previously generated, I will have the DEM, the mosaic, the point cloud, and the 3D model. And I can select what output that I want to export. One element that's important is the DEM that will be exported is the DEM that is selected in your project tree. So if you want to export your digital surface model on Cesium, you will need to check in the digital surface model in your project tree in order to export it. And also, same thing, if you have multiple point cloud, well, all the output that you want to share needs to be selected in your project tree. You can also set the band order here. So you can, if you want to reorder your band, if you have access to maybe multiple band, such as multispectral camera, you can set different output bands in different orders. And once this is all done, basically what the tool is doing is it's gonna take all your outputs, reproject it into a web projection, and it will give you at the end a link with all your shareable content. So you're gonna have a link that you can take it and then send it to your output customers. Also, the uploaded data can only be deleted using the Cesium account webpage. So you can delete all your upload data directly from your Cesium account. But if you are creating a second upload with the same name that you already have preserved, well, the data will be overwritten on your Cesium account. So this is also an important element for cloud sharing the output data. So yeah, so again here, so if you want to share your output results, so you go to File, share results, and you can select the output that you want to upload directly on Cesium, and then once it will be done, you will have access to the link with all your data on the web. So as I can show you here, once it is all done, in this case, I have basically I have a mosaic and a DEM that are edited. So I can see here I can pan into the SimActive the data viewer, and I will have I will be able to pan or to take a look at my final mosaic, and also I can here uncheck the mosaic, and I can see my digital surface model here like this. And also uh, another important tool is here you can play with the lighting condition, which gonna have an effect on how you can on how well you want to see the details over your terrain model. If you add other elements such as a 3D model or a point cloud, well, you can see here all other checkbox will be able to will be available here. You can always come back to the home view every time you want with the little house here. Um, and this is the link basically that the software will create. So it will create basically a long link that can also be retrieved within your correlator 3D log file. So here in your log file, you'll be able to see shareable links, and you can copy paste this link as you can see. So it's a long link, and then type it into a web browser to share your output data to your customers. So again, the implementation of a web platform to share your output result was gives Correlator 3D unique benefits. So it can allows anybody to quickly share output data to your customers within a matter of minutes. Um, so your end user, your customers can really show quickly where are the project, where you are in your deliveries. It can really show the output of the project, and it's a good alternative to some GIS software only for visualization because it's much more simple to use than installing, let's say, other complex GIS software. So again, Correlator 3D can bring you some unique benefits to your processing. So we have unmatched processing speed. Most of the processing is done on the GPU and on the SSD drive, and also the CPU. So we're using most of the performance of your computer to generate as quickly as possible some mapping product. We also have no training required, so we have an automatic solution with the one button click solution that I call the automated workflow. Also, this we also have each individual module that you can go module by modules to play with the parameters. You can process unlimited numbers of images on a single standard PC. So we have project that we have customers that project images of thousands of images, and also the software can be installed on a cloud-based approach such as AWS or Azure, and also everything can be run within the command line. So it can be. It can be done without having to open the graphical user interface. Again, here we're offering also different types of pricing. So we have flexible pricing option. We offer monthly, yearly, or permanent license for Correlator 3D. We have also different types of licensing. So we have the UAV license, the medium format license, the full format, and also the satellite format, depending on the data you want to process. And also we offer two types of of floating license, such as the node loc or the floating license, depending on your needs. Again, if you want to get started with Correlator 3D, we offer free processing for marketing purposes. So you can contact us at sales@simactive.com, and feel free to download a free trial, which is also available on our website. Thank you for joining today's online presentation. So my name is Simon Grandin, and I'm the photogrammetric workflow specialist. And we hope to see you soon for another exciting webinar. Thank you very much, and have a great day, great rest of the day. Thank you.